All right, so again, we are in our additional notes section. We are drawing this table into our notes. Remember, we're going to need a little bit of extra room over here on the left-hand side, so leave like an inch or two in your additional notes section on the left-hand side so that we can add something in over there. And we have these 4 columns. We have the graph, the name, the degree, and the equation. And I'll give you just a minute to draw this in. And then we'll get started in talking about what goes in those boxes. All right, perfect. So on that previous slide, we saw a parabola. We saw a quadratic equation. We looked at the parent function of it. We said it was an x squared parent function, since a parabola comes from the equation y equals x squared. We looked at the important points. We said the vertex is the important point of a parabola. Yes, we just won't use it that often in what we're going to be doing now. 2 other points we said we will use very often are the x-intercepts. So whenever we look at the graph, we're going to look at x-intercepts, and those are going to be really important to us. And then the y-intercept will also be important to us, but the x-intercepts is where we will spend our focus. So the first function I want to look at is a linear function. And somebody shouted out earlier that the equation of a linear function would be y equals mx plus b. So go ahead and fill that in your chart. Y equals mx plus b is like the basic form of a linear equation. It's called slope-intercept form. We won't deal with these too often in this class, but hopefully it looks familiar dating back to IM1, probably about 2 years ago for most of you guys. When you're in IM1, you started learning about linear functions. And this is what the graph of a linear function looks like. So write that down as well in your table. A linear function is just a straight line. Hence the word linear kind of has the word line in it. That's where a linear function comes from. Now look closely with me at this graph of this linear function, and I'm going to put a purple dot where the x-intercept is. All right, I put that purple dot there. How many x-intercepts does a linear function have? 1. Okay, good. Keep that in your head. Then the next type of equation, the year after that, after you guys were in IM1 and IM2, you guys learned about quadratic equations. So there's the next line down. The next function we'll talk about is called a quadratic equation. And we just said that the parent function for quadratic is y equals x squared. We're moving on up in this world. We started at y equals x to the first power. Now we're at y equals x squared. And this is what a quadratic function looks like. It looks like a parabola. And if a linear function had 1 x-intercept, how many x-intercepts does a parabola have? It has 2 x-intercepts. And that leads me to this column that we've left blank so far. We haven't filled in anything in that degree column yet, and now we get to do that. So in that degree column, we're going to talk about what the degree of each of these functions is. For a linear function, we call that first degree. So in that degree column, go ahead and put first degree. And for a quadratic function, we call that the second degree because there are 2 x-intercepts. It's x to the power of 2, or x squared. For a linear, it's x to the first power, and there's only 1 x-intercept. Do you know any more beyond this? So we've looked at first degree, second degree. Are you familiar with any of the other degrees for these polynomials? My other classes weren't either, so I'm not surprised that you're not. We're going to learn about some of them today, and you guys are going to write some down. Their names are kind of interesting and unusual, so we'll get there. All right, perfect. Now, we're going to write down some vocabulary. You're going to write it underneath this table. However, we're still going to add more rows to this table. We still need to add 3 more rows to this table. You've only written 2. So can you do me a favor really quick? Below where you already wrote, can you add 3 more blank rows beneath this table? And they'll probably take up about the same amount of room. So however much room you already took, draw 3 more rows underneath it that are blank. We'll come back to those. And if you ran out of ran out of room on your page, because some people in my earlier class, when they did that, they ran out of room. They wrote so big. If you ran out of room on this page, just flip it over to the next page. But if you think you still have some room on this page after you do your 3 rows, if you think you still have some room, then underneath it you can write vocabulary. Yes, ma'am. it goes up to infinite number, but we're actually going to talk all the way up to 5. Okay, so underneath that, we're going to write vocabulary. So if you haven't already, write that term, vocabulary. There are 3 vocabulary words that we're going to start off today learning. I think they're actually pretty familiar to you. I don't think any of them will be too new. I don't think any of them are going to be revolutionary. I think you probably heard most of them already. The first one is x-intercepts. I know you've heard that because you told me what they were earlier. So do me a favor and write this down where you wrote vocabulary. It says x-intercepts, the coordinate where the graph intersects the x-axis. We knew that. We just said that a linear function has one x-intercept, or one time where the coordinate intersects the x-axis. We said that a quadratic function has 2 x-intercepts, or 2 times that it intersects the x-axis. The main reason I need you guys to write these vocabulary words down, however, is because I care a lot about how you write them. If I ask you to tell me the x-intercept of a function, I want to make sure you write it in the correct form. So that next bullet point that I just threw up there, that's how I want you guys to write it. Whenever I ask you to write an x-intercept, you're always going to write it as x comma 0 in parentheses as a coordinate, where the x value is the x coordinate of your x-intercept, obviously, and the 0 represents the fact that it's on the y-axis. There is no height to your point. The next vocabulary word that is important to us. Do you guys know there are 3 words that are interchangeable? X-intercept, and then there's 2 more. One of them starts with an R, one of them starts with a Z, and they all mean the same thing. They're synonymous. Do you know what they are? X-intercepts is one of these words. All 3 of these things mean the same thing. X-intercepts is one of them. Another one starts with an R, and another one starts with a Z. Roots. Roots is one of them. Do you know the third one, the one that starts with a Z? Zeros. The zeros. Good. We're going to use those 3 words interchangeably, meaning that they all mean the same thing, essentially. Roots, zeros, x-intercepts. So x-intercepts are the coordinates where they intersect the graph. The roots, here's your next vocabulary word. I want you to write it down. The roots, the x point where the graph intersects the x-axis. So again, the definition is pretty similar to that of x-intercept, not too interesting or radical maybe. But the difference, the main difference I want you to take away from that is that for roots, we don't write them the same way that we write the x-intercepts. Notice that for x-intercepts, they're written as x comma 0, but for roots, we just write them as a list of numbers. So it would be written as x equals a number, comma, a number, comma, a number, etc., depending on how many there are. So maybe for an x-intercept, you might write, oh, the x-intercepts are 1, comma 0, 2, comma 0, 4, comma 0. But for roots, you would just write it as x equals 1, comma 2, comma 4. You don't need to write them as coordinates. And the last vocab word that I need you guys to write down right now is zeros. And remember that zeros is that third word, and it's equivalent to roots. It has the same definition as roots, and we even write them the same way we write roots. So those 2 especially are definitely interchangeable. Roots we can write as x equals a number, number, number. Zeros we can also write as x equals a number, number, number. So the only one that's really different is x-intercepts. You need to make sure to write those as coordinates. All right, when you're done with that, shake out your hand. We're going to write one more thing in our table, and then we get to do some examples. I don't know why I'm shaking out my right hand because I'm left-handed, but it's okay. And I haven't been writing anything. I've just been clicking buttons. All right. If you're not done writing this yet, it will come up again. So if you still have a couple more things you need to write, know that this slide will come up again in just a minute. So if you need to catch up on some stuff, you can catch up on it when we get to there. So I know I'm going a little fast for some of you guys, but like I said, I'll leave it up there in just a minute again. All right, let's talk about this one. Count for me how many x-intercepts there are. Ready?
1, 2.
Perfect. There are 1, 2, 3 x-intercepts. Can you list them for me? This one would be what?
-3.
Negative 3, 0. This one would be what? Negative 1, 0. This one would be 2, 0. Good. That's how I would write them if I said, what are the x-intercepts? What if I just asked you for the roots or the zeros? What would you say? The roots are negative 3, negative 1, and 2. Good. You would write x equals negative 3, comma, negative 1, comma, 2. How many x-intercepts are there in this function again? 3. So it's not linear. A linear function only has one x-intercept. It's not quadratic, because a quadratic function can only have 2 x-intercepts. So this one must be, do you know what it's called? Close. We call it a cubic function. Good. And we're going to add that really quickly as our next row in our table. So this one is a third degree polynomial. It looks like y equals x cubed. We call it a cubic function. And the graph looks like this, where it has 3 x-intercepts. All right, so we have linear, we have quadratic, we have cubic. I know that you know there's 2 more rows coming because I told you to draw a table with 5 rows in it, so be aware of that. There's 2 more rows coming, but we're not going to write them quite yet. We're going to come back to that. So if you finish drawing this row, can you flip back to page 7? We're going to spend some time on page 7 right now. So go back to page 7 in your packet. And with the exception of number 3, because number 3 says to find the factors. We haven't talked about factors yet. But we have talked about roots, we have talked about zeros, and we have talked about x-intercepts. Can you guys do me a favor on number 3? Everybody look at that one. Can you cross off the word factors? Everyone cross off the word factors on number 3. All right? And instead of finding factors right there, can you write the word roots? So we'll put a pin in factors. We'll come back to factors. Right now we're just going to write roots. And I'm going to give you guys a few minutes. I want you to write whatever it says to write. If it says find the roots, then write the roots. If it says find the x-intercepts, find the x-intercepts, etc., etc. Take 2 minutes and write down all of the roots and or zeros and or x-intercepts for numbers 1 through 4. Good. So I see some of you guys just staring. Make sure that you're writing. Do numbers 1, 2, 3, and 4. Take about 1 more minute. Make sure you've answered all of them. 1, 2, 3, and 4. And remember that for number 3, we're not finding the factors, we're finding the roots. $30 seconds left. Make sure you've answered all of them. 1, 2, 3, and 4. Check with your neighbors next to you if you're done. Make sure they got the same answers as you. All right, eyes up here. Thank you to those of you guys who have your eyes up here. I'll wait for those of you guys who are almost done. Thank you very much. Some of you guys wrote them in the incorrect way, and it's only a small, minute detail, but I will ding you for it if you don't have it the correct way. If I say list the roots, I want you to write x equals. If you just listed the numbers, can you go back and change it to say x equals? And then shout them out for me. What are the roots for the first one? 1, 2, and 3. Perfect. So I want you to write x equals 1, 2, 3. For the second one, it says list the zeros. And remember that zeros are written the same way. So we're going to write x equals and shout them out for me. What are the zeros in the second one? -4, -1, and 5. Beautiful. On number 3, we crossed off the word factors. I hope you guys did that on your papers. We crossed off the word factors and we wrote the word roots instead. So we have x equals. Shout them out for me. -3, -1, 1, and 3. Perfect. That one's a nice, pretty, symmetric function. Now be careful. Did you write the last one correctly as x-intercepts? Did you write them as coordinate points? All right. There are how many of them? 5. There are 5. What's the first one all the way to the left? -3, 0. What's the next one? -2, 0. What's the next one? -1, 0. What's the next one? 1, 0. And the last one? 2, 0. Perfect. All right. How many roots were there on number 3? How many roots were there here on number 3? 4. How many roots are there here on number 4? 5. Do we know what those types of functions are called? When there's 4 roots, it's a 4th degree polynomial? Or when there's 5 roots, when there's a 5th degree polynomial? Anybody? It's okay. Again, I don't expect you to know it. If you did, I'd be amazed. All right, we're going to write these in. So go back to additional notes. Find that pink Post-it. And let's fill in the last 2 layers of our chart. We talked about linear, which is 1st degree. We talked about quadratic, which is 2nd degree. We talked about cubic, which is 3rd degree. The next one is called quartic. Quartic. Go ahead and write that down for me as the next row in your chart. A quartic function is a 4th degree polynomial. It looks like y equals x to the 4th. And it has 4 x-intercepts, so the graph looks like this, where it goes up and down and up and down and up and down and crosses through 4 times. And again, we call that quartic. Our 5th and final row is the quintic row. It's a 5th degree polynomial called quintic. We have y equals x to the 5th. And the function looks like this. It goes up and down, up and down, up and down 5 times. It crosses through the x-axis. Now, those names might be a little difficult to remember sometimes for some of you guys. I'm going to tell you what. I prefer, and I would really appreciate, you calling them by their actual names. When I say it in class, I will call it by its actual name. So if it's a 5th degree polynomial, I'm going to say that this is a quintic polynomial. If it's a 3rd degree, I'm going to call it cubic. If it's 4th degree, I will call it quartic. However, with that said, if you don't quite remember on a test or a quiz, and I ask you to classify, if I say, what type of function is this? Tell me the name or classify it. If you called it a 4th degree polynomial instead of a quartic, I would be okay with that. All right? If you called it a 5th degree polynomial instead of a quintic, I would be okay with that. I would prefer that you knew its name, but if I can get you to come up with a degree, I'm okay with that. Sound good? All right, perfect. We have a couple more things to write down, so shake your hand out one more time. Give it a little rest. All right? Who knows what these 2 words mean? End behavior. Have you heard those words before in a sentence? Yeah, absolutely. So here's the thing. We eventually we will get to end behavior, and we're going to write it the right way. And I think some of you guys already know the right way, because last year, the IM2 teachers, for the most part, told us that they taught you guys how to write it the right way, which is awesome. When we get there, I think it will be easier for you because of that. However, right now, I don't care about how you're actually going to write end behavior. The only thing I care about is that you know the pattern or know what's happening at the end of the graph. And here's what I mean. This is a degree 2. Do you remember what we call a degree 2? What's the name of a degree 2? Quadratic. This is degree 3. What do we call it? Cubic. This is degree 4. What do we call it? Quartic. This is degree 5. What do we call it? Quintic. Good. I know you guys are looking at your tables, but good still. Even that you know how to pronounce them, that's perfect. Do you guys see that bold line that divides them in half? Can you tell me why I would group these two functions on this side and why I would group these two functions on this side? Yeah, these two have even degrees. 2 and 4 are even degrees, and these are odd degrees. 3 and 5 are odd. There's another reason, though, and I want you to look at the graphs. Can you tell me, based on the graphs, why these would be grouped on this side and these would be grouped on this side? Yeah.
Well, like the even ones look like they have bigger loops.
Okay, good. What else? Yeah.
Arrows on this side.
Yes. Notice that the ends of the graph on even functions, both of them point up in both directions. Here and here, they both go up. On odd functions, they go in opposite directions. It goes up to the right and down to the left. Up here, it goes up to the right and down to the left. Can you guys write this underneath your vocabulary? I don't need you to write the whole thing, but maybe just this part that I'm going to highlight right here. That highlighted part, I know it's kind of ugly, sorry. You'll get over it. All right, this highlighted part right here, I want you guys to write that into your notes underneath your vocabulary. I want you to know that when it's an even degree, they both go up, or they both go in the same direction. When it's an odd degree, one goes up and one goes down. They go in opposite directions. And it's always up to the right and down to the left until we introduce negative orientation, but we're not there yet. So for right now, it's always up to the right and down to the left. All right, get ready to be excited because we only have to write one more thing into our notes. And then we get to do the last part of our examples and we're done for today. So we're going back to our vocab. We're going to write in one more vocab word. So find your vocabulary section. Find your vocabulary section. The last vocab word we're going to write in right now is factors. Factors. It's the fourth bullet, I believe. We have x-intercepts, we have roots, we have zeros. The last one is factors. All right, here's the definition for factors. It says when you're given a root, or you're given a zero, or you're given an x-intercept, or maybe you just read it from the graph, sometimes we'll ask you to write them as factors. And factors are preparing us to go back and write the equation of what the actual polynomial equation is. So notice that these ones are a little different. They change from x plus a number to x minus that number. Or vice versa. If it was minus, it changes to plus. For example, I'll give you guys an example over here. Bless you. If you had x equals 4 as one of your roots, to put it back into factored form, you're essentially subtracting 4 back to this side. So you have x minus 4 equals 0, and that is called a factor. So notice how these two things relate to each other, but they're kind of different. X equals 4 turned into x minus 4 as a factor. I'll give you one more example. If you have x equals negative 2, we would move that 2 back over to this side and have x plus 2 equals 0. So again, notice how it's the opposite of the roots, or the opposite of the factors. And again, these factors are going to help us when we start writing the equation of the function. If you can figure out each of the factors, then you can figure out how to write the equation. When you're done writing that vocab word, go back to page 7 for the last time. This is the last time we're going to go back to page 7 again. And I want you to spend some time writing the factors for numbers 1, 2, 3, and 4. I'll do the first one with you. All right, so on the first one, as a reminder, Our x-intercepts were 1, 2, and 3. So when we write the factors, we're going to do the opposite signs. It will be x minus 1, x minus 2, x minus 3. But make sure you write it like this. We're going to say these are the factors. I want you to also write that these are the factors. We'll say x minus 1, x minus 2, x minus 3. Those are the factors of this equation. So for number 1, those are your 3 factors. Spend 2 minutes writing the factors for the other ones. Number 2, 3, and 4. Spend 2 minutes writing those factors. And when you're done, because I see some of you guys are almost done already, you guys are quick. When you're done, check with the people next to you. Make sure you have the correct factors. And be careful with that last one. Your factors should look the same as the rest of them. Just because we wrote the x-intercepts differently doesn't mean your factors should be written differently.
What one you should start with the 0 2?
So they use them just like these ones. You have 1 minute left. You guys are good.
You're adjacent. I'm adjacent. You are. You're sitting adjacent. I have your best shot. No, I didn't even know you were
Almost.
Now we're gonna go 5 to 10. Okay. Oh yeah, I heard the fire. No.
All right, 2 minutes is up. Check your answers up here on the board. The factors for number 2 are x plus 4, x plus 1, x minus 5. For number 3, x plus 3, x plus 1, x minus 1, x minus 3. Number 4, x plus 3, x plus 2, x plus 1, x minus 1, x minus 2. Yes, sir. No, it doesn't matter what order you write them in. All right, do me a favor. All right, you guys are done taking notes for today. We don't have to come back to this again until tomorrow. Rest your hand. I know that was a ton of notes. You don't want to come in on Saturday? Okay. We'll come back Monday then. We'll come back to this on Monday. Put that away and get out your homework so I can come around and stamp it.